In this video we're going to find answers for this question. To move forward with this problem, we first need to let the length of the tank be y meters. It is then easy to write an equation for the surface area. We have 2 times the square sides, and we've got 3 rectangles x by y. We can now also write an equation for the volume. We are aiming to find the volume in terms of x, so we need to eliminate y from the equation for volume. So let's do this by first making y the subject in this equation. We now need to substitute this into our equation for volume. So that's done. That has been substituted into there. We now need to simplify this equation. This is the tank's volume in terms of x as required. We can now use differentiation to find the maximum or minimum volume. The maximum or minimum point occurs when dv by dx equals 0. Rearranging this, we can find out what x is. X is a length, so x equals 6 meters at the maximum or minimum volume. We need to look at d2v over dx squared to decide whether the volume is maximum or minimum when x equals 6 meters. Here it is. When x equals 6, d2v over dx squared equals negative 24. As this is negative, our volume when x equals 6 is a maximum, and if we substitute x equals 6 into our equation for volume, we will get the maximum volume. And this is 288 meters cubed. I'll take a picture of the whole working in one go so you can see it all together. I hope this has helped. Thank you for watching.